Okay, howdy guys, and welcome to PA1. In this video, I want to go over the different functions that you need to complete and the different functionality you need to implement in order to finish PA1. So this is going to be a little bit of overlap between this video and Lab 1B. Hopefully between the two, you get enough information to get started. So the premise of this PA is that we have a client and a server. The server has this database of 15 different files. Each file in the database represents one patient. And inside of each CSV, you can see there are 3 different columns that all have ECG data for that patient. So the first column is time. It's the timestamp. Time is going from 0 to like 3996, something like that, by 0.004 increments. And the next 2 columns are ECG values. So you have ECG value 1 and ECG value 2. The client is going to be requesting either the full file for the patient or a specific data point or 1,000 data points inside of this file. So based on what the user specified in the command line argument, you'll be modifying the request to the server. Before you start coding client functionality, I would like you to start the server as a child of client. This is a different approach than starting the server in a separate terminal and having the client run in a separate terminal. We are going to run them both in the same terminal, and we're going to do that using fork and execvp. So after you run the getopt while loop, you'll want to kick off the server, and you definitely want to kick off the server before creating the control channel. So we're going to do that by specifying, or just give arguments for the server. And the arguments for the server is going to be, So the server needs the path and the -m argument and the value for the -m arg. And then at the end of every argument list, you need to give a null pointer, and that lets execvp know that we're done giving arguments to the command. So once you do that, start fork. In the child, run execvp using the server. And specifics on how to use exec in a child are given in lab 1A and 1B. So if you're not super clear on how to do this, go ahead and go back to that lab and review how to run exec in a child. What I alluded to here was we need the -m argument and values for the -m. So the -m is the buffer capacity. It is the maximum number of bytes that the server can send to the client and the client can send to the server. I go into more detail later on how to, or why we need them and how to use it. But for this example right now, let's just add m to the getopt statement. For this, you'll need to add a m variable. And we want to initialize it as max message because that's going to be the default value for buffer capacity. And just like we did before, we're going to be using ATOI to convert optarg to an integer. Cool. So you're going to be using this value that we get back for m in this position in the arguments for the server. Okay, So now let's start by looking at the request we're going to send to the server. So the first thing is going to be obtain an individual data point from the server. So if you go to the common.h file, close that guy out too. If you go to the common.h file, you can see that there's this enum called message type, where it holds either a data, file, new channel, or quit message type. For the data message, there's a corresponding class that we need to fill out. So the class has the message type class, which should always be data message, person, seconds, and ECG number. So the person, seconds, ECG number, that corresponds to the file that I just showed you before. So if we're looking at 5.csv, that's going to be person 5. We choose a random seconds. So if you choose 0.072, that's going to be the time value. And you can say either ECG1 or ECG2. So if you get all 3 arguments from the user, the server will give you back that specific point value. So let me show you an example on a working system. So if we start up our client and we say we want person 5 at time 0.072, and I want ECG value number 2, we format that request by creating an instance of data message, send the request to the server, and receive a double reply back. So for this example, we got a 0.035 response from the server, and that's what it should be here. So that's the idea. Let me go into the starter code to show you how you're going to be implementing this. So the first thing that you want to look at is the get opt statement. So in get opt, you can see it has this string, and this string is all of the flags that that we support, that the user can specify. And then it goes into a switch statement. So this while statement iterates through every flag that the user has given you, and this switch statement deals with each flag that we support. So we're giving the value of P, T, and E, and this is just parsing the reply or parsing the user's specified options and getting the values from the command line. So once we parse the values, they should be populated in P, T, and E. We can take those and put those into our constructor for data message. Right now, X is hard-coded to patient 1 times 0 ECG1. You want to actually put in real values. So we want to change from hard coding to users' values. And then we need to send that request to the server. So in this example, we have buff. We copy our request into buff, and then we write it to the server through our control channel. Create a reply. So that's just a double that's going to store the value that the server gives back, and then output it to the terminal. If the user has only asked for 1 point, all we need to do is send that response to the terminal. If they ask for something different, we might actually write to a file. But that covers the first part of the data message request. The next part is a little bit more complicated. It's when the user wants the first 1,000 lines of a file. So let's go to the working system again and say that the user specifies only the -p argument. So let's say I only want patient number 4. Oh, also, if you don't already have it, if you have just cloned your repo, you won't have the directory received yet. So you'll want to run the command make dir received. I've already created it, so it's going to give me an error, but make sure you have a received directory so there's something to write to. But anyways, back to the example. If the user only gives the patient number, this is when you want to ask for the first 1,000 lines instead of just 1 point. And it does take a little bit to run, but once it's been processed, you can see that there is a file in my received directory called x1.csv. Ignore this guy for now. Let me delete. We're just looking at x1.csv. And if we check out this file is the first 1,000 lines of the patient file that we've requested. So in this example, it's the first 1,000 lines of 4.csv. And it's formatted the exact same way as the source file. What we had to do to create this file was send actually 2,000 requests because we're asking for both lines or both columns. So we iterate through every time we add 0.004 to the seconds value for every request, and we ask for both ECG1 and ECG2. So let's go back into the code and see how you would implement this. So if we go into our client, we only want to run this section if PT and E has all been specified. And the way that I tell people to know if the user has specified something or not is actually by modifying these initial values. So if we set these to values that aren't supported, you can tell if the user has modified them or not. So if we say PT and E all start at -1, since those aren't valid values for those parameters, we know that if they stayed at -1, then the user hasn't specified them. So yeah, so we only want to run single data point when P, T, E not equal -1. And then if else, if P is not equal to -1, request 1,000 data points. So you can see how that works. If all of them have been specified, do a single data point. If only the person has been specified, do 1,000 data points. So after this, it's again just putting this into a loop. Loop over the first 1,000 lines, and you'll need to send request for ECG1, send request for ECG2, and then write line to received x1.csv. So this is what the loop is going to be doing. It's going to be the same structure. So we're still going to be using a data message request. We're still going to be receiving a double as a reply, but we're just going to be doing that 2,000 times and writing to x1.csv. A lot of people ask how they need to open the file. I don't really care. You can use file stream. You can use file, anything that makes sense. Use fopen, however you want. There's plenty of examples. But all that you need to do, all that you need to make sure of is that when you write to the file, it matches this format. So it matches T, comma, E1, comma, E2. Yep. So that is 1,000 data points. Next is sending a file message. So when we're asking for a file, let's go back into our working code. The user is going to specify the -F option. Let's say we want 8.csv. Now what the client is doing is sending a new type of request, a file message request, and receiving byte chunks as response, and putting this all into the received directory under the same file name. So now I have 8.csv. It should also match the format as the source file in BIMDC directory. So you should be able to request any file that's in this BIMDC directory. It does not have to be a CSV file. It can be a text document. It can be a executable. It can be a binary. It can be a video file. Any file type should be supported by your code. And what that really means is treat it as a array of bytes. Don't treat it as a string. So don't do any sort of conversion to string. Keep it as a char star, and you should be good. So as you can see, we have just transferred this 8.csv file. And to make sure it's the same file, you can use the diff command. So you can use diff, and all you need to do for diff is specify both the source file and the destination file. Source file is going to be in BIMDC 8.csv. The destination file is going to be received 8.csv. And you can see that they're the same file. If they weren't the same file, you would get an error output. So you would get lines that say this is where they diff. But since they're the same, you won't get any sort of output. Okay, so let's go into the starter code to show you how you might implement this. Oh, actually, first I want to now let's I'll do a little bit here and then I'll draw some stuff out. But in the common.h file, we're going to be using this file message type now, and it corresponds to a class as well, where we're going to be specifying the offset and length for the file message request and receiving back a response from the server that is length bytes long. So let's now go into drawing stuff. So when we're requesting a file, the user can give the file name, which is a required parameter, and the buffer cap, which is an optional parameter. So the -f and the -m option. I want to talk a little bit about the buffer capacity parameter. So buffer cap specifies how many bytes the client is allowed to send to the server and the server is allowed to send to the client. It can't go above that. The length of the file is definitely going to be longer than the buffer capacity. So we'll need to split up the file into segments where we request only one segment at a time. So let's say we have a file that is 550 bytes long. And let's say we have a buffer capacity that is 100 bytes long. We need to split this up into segments that are at a max 100 bytes long. So in this case, we're going to need to split our file up into 6 segments. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, more or less 6 segments. And we're going to create a file message for each segment and give the offset and the length based on that. So let's create, a little table that has our offset, our length, and as well as the remaining bytes. And the reason behind the remaining bytes I'll explain in a bit. But for the first file message request, our offset is going to be 0 bytes. The length is going to be 100 bytes. And the way that we specify, or the way that we find the value of the length is the minimum of either the buffer capacity or the remainder of the file. So in this case, the remainder of the file is 550 because we haven't received any bytes back. So we know that the minimum is going to be our buffer capacity. So that's going to be our first request. Our second request, we have moved down the file 100 bytes. Our length is still 100, and the remaining bytes is 450. And you can see how this goes every time we update the offset and update the length if it's required. So I'm just going to skip through this stuff. Okay, so when we get to our last segment, we notice that the remainder has gone down to 50 bytes. This is less than our buffer capacity. So we want to use the minimum, so our length is going to be 50. We do this because if we request more bytes than the remainder, we will receive an error back from the server. So you need to be very careful when you're setting the length that you don't exceed the number of bytes in the file. So by updating the length, we make sure to stay under the number of bytes that are left in the file. So now that we have set all of our segments and the file message that correspond to each segment, let's figure out how to send these to the server. So a file message request consists of two parts. So the first part is going to be our file message. So it's going to be the class that we talked about before, this file message class, where it has the M type, the offset, and the length. So what we have created in our table, and you create this by just calling an instance of the class file message. The second part of our request is going to be the name of the file. In this case, did we give a file name? Nah, let's give a file name. Let's say we're creating 8.csv. So inside a file name is the string 8.csv. So it's very important to be clear on this. File request is not just file message. It's file message plus file name. And I'll show you an example in just a bit. But this is the idea. It's pretty clear how you could make a for loop that goes through every value of each segment. Yeah, send it, receive a response. The next thing I'm going to talk about is this buffer. You're going to have a buffer for a request. And you're going to have a buffer for a response. These buffers are not the same length. So the request buffer is going to be size length, which is equal to the size of a file message plus the size of our file name. The buffer response is going to be size of buffer capacity. It's very important to be clear that these are not the same size. So you'll need to have two different buffers that are doing two different things, and they're two different sizes. So let's show you in the starter code what that looks like. So if we scroll down to our file message example in the starter code, you can see us creating a file message and setting up our request buffer. So the first thing, something I haven't talked about yet, we need to ask, the first thing that we need to do is determine how big our file is. So in this scenario, we've said our file is 550 bytes. We get that by querying the server. So we can ask the server how big the file is by sending a file message that's just 0, 0 with the file name. So this goes into what I said before, where we've created our file message instance. And then we create this buff2 that is size length. So it's the size of the file message plus the size of the file name plus 1, since we need to add a length for the file terminator or the null terminator at the end. So we copy the file message into the buffer, and then we copy the file name into the buffer, and then we send our buffer to the server. This will return the file length. And let's code that. So you'll need a variable that stores the file size. And I recommend, you can default that to 0 if you want. I recommend using a N64 just because these files can get pretty long and that's the type that the server responds with. And then just like what we did before in our data request, we're going to be reading the response from the server with cread. We're going to be reading into file size. And the size is going to be size of int 64t. Oh, so this does the first part of the of what you see in the example. This will receive the file length, and then that's when we get back the file length, then you know how to segment up the file in our example before. So once we have the file size, we're going to put this into a loop. Which is going to be file size divided by buffer capacity. Again, remember that the buffer capacity has been specified by the user with the -m argument. We haven't given you that in getopt, but you will need to get that from the user. Let's see what that. So the buffer capacity is going to start out as defaulting to max message. But the user is going to give you a different so this allows the user to change the value of the -m argument, buffer capacity, or m. Okay. And then, so once we're in the loop, you'll just want to create your file message instance. And what I like to do is just reuse buff2. It's perfectly fine to reuse buff2. And you can do that by saying file message file request is equal to and we want to make sure that that's a pointer. So I do this by just casting buff2 to a file message pointer. And you can cast in C++ any pointer of one type to a pointer of any other type, as long as you know that the structure of the pointer is the same. In this case, we do know because that's what we've mem copied to the beginning of the buffer. This just converts it back into a file message from a char star. And this allows us to reuse buff2 when we are creating our file requests. So the next thing that you want to do is set the offset. And to do this, I would just point you back to this table that we've created here. You're going to need to do something like this to determine where you are in the file. And again, set the length, be careful of the last segment. And then receive. First, we need to send the request. And since we're reusing buff2, you can just reuse buff2. So really, it's just going to be this same thing. So receive or send the request. Receives the response. So like I said before, the response buffer needs to be different than the request buffer. So in our case, the buff2 is just the request buffer. So let's make a response buffer. It's also going to be a char start. Let's call it buff3 for fun. And it needs to be large enough to store the biggest response from the server. The biggest response from the server is always going to be buffer capacity. So if you create a buffer of size M, you should be good. Just make sure that you also delete it down here. Delete buff3. So receive the response. And that's just going to be a C read into buff3. And length is going to be file rec length. So when we're doing a C read, you always, or a C write, you always need to specify how many bytes you're reading or writing. In this case, we're going to be reading the length that we specified here. Cool. So once you have received the response, you need to write buff3 into a file, which is going to be file received file name. And again, we've hard coded the file name to be fname in this garbage.dat file. Instead of using this hard coded value, you'll need to use the value that the user has given you in the -f argument. So it's this file name. And then update the remaining bytes and loop as you want, and that should be good. That should be the end of what you need to do for requesting a file. Okay, so the last thing that you need to do to finish up PA1 is to create a new channel. So let's go into the PowerPoint, and I will show you where it points out creating a new file. Okay, here we go. So it is slide 19, and then in the PowerPoint, I've just blown up the picture because I like the picture. So when you're creating a new file, this is going to be or a new channel. This is going to be specified by the user with the -c argument. And all this means is we want to create a new channel, and that new channel should be used to transfer any request that the user specifies. So in this example, we're going to be creating a new channel, and the file request should go through that new channel. So the file request for 5.csv should go through the new channel. The output should be totally the same. So if you're requesting a data request, you should see a point on the terminal. If you're requesting 1,000 data point request, you should see the x1.csv. And if you're requesting a file, you should see that file in your received directory. So back to the picture. To create a new channel, you're going to be using the control channel to send a new channel message to the server. And remember, since we're using named pipes, the client and the server both have to agree on the name of the pipe. So the server is going to create the name and send back the name to the client, and they can both call the FIFO request channel constructor to establish the channel. And if we go to common.h, you can see that we have a new channel message type in our enum. So this is the byte that we're going to be sending to the server so that it knows to create a new channel. It does not have a class associated with it. All you need to do is send that byte. And what I recommend doing in main is create a Boolean, call it, I don't know, new chan, set it to false. And then in your get opt, we need to support the -c argument. So just add a C. I am not adding a colon after C just because the colon is used when a flag has a value associated with it. Since it's a Boolean, if the flag exists, we know that we want to create a new channel. It does not need a value. And then we need to support it. Instead of C, what did I call it? New chan. Cool. So now we have supported the C flag in our user options. And then somewhere after you create the control channel, because remember we need the control channel in order to send our message, we want to create our channel. So in this case, if new chan, let's create a channel. So the first thing we do is send new channel request to the server. And a good example of sending just a 1 byte request is actually the quit message. Because a quit message, again, is you're just sending that byte. So we're going to use a very similar function. So I just recommend copying this guy over and we're going to modify it. Call it whatever you want. Instead of quit message, it's going to be new channel message. And we're going to be writing to the channel. Okay, so this is sending the request to the server. So this does that the first step of creating a new channel. Now we need to receive the name from the server. So we need to create a variable to hold the name. And you can do a char star, you can do a string, however you want to hold the name. See the response from the server, and then call the FIFO request channel constructor with the name from the server. Yeah, I recommend dynamically creating your channel because we're inside of an if statement and we want it to exist outside of our if statement. So make sure to call new with the constructor just so that you can use it outside of the if statement. And this leads me to the next point of creating a new channel is once we have created the new channel, you want all of the requests to go through the new channel. So you want all of this code to go through that new channel. There are two main ways of doing this. The first way I don't really recommend. So the first way is pretty obvious. You can copy and paste all of that code into your if statement. This violates dry coding standards. So this, you're going to have two redundant copies. It looks really ugly. I recommend not doing that way. The second way of doing this is creating some sort of structure to hold all of your channels. And then when you're calling these requests, you just need to call the correct channel. So how I recommend doing this is creating a vector. You can use an array if you want, however you want to do this. FIFO request channel star, we want to use pointers just because of what I talked about here with dynamically creating them. Create your channel vector. Once you've created the control channel, you can push the control channel into our vector. And then once you've created the new channel, into the vector. Now, when we get to this part of the code, so when we get in my code, it's line 65. When we get here, you know whether or not you've created a new channel, we want to use the last channel in our vector to send all of our requests. How that works, we want FIFO request channel chan to be channels.back, right? Because whichever channel was the last to be pushed back is the channel we want to use. And then just make sure to dereference it since we want to use it as a object and not a pointer. So now that we've created our chan, you don't need to change any of the remaining code. You can just use chan like we used before. You probably want to call the control channel something other than chan, just so that you don't have two different things called the same name. But that's really all you need to do. It's pretty straightforward. Just use the last channel in your vector, and then you don't have to duplicate any of the code down here. Last thing that I will mention is we have called the FIFO request channel constructor dynamically. So we've used new, when we use new, you need to make sure that you delete. So at the end here, probably right before you close the control channel, if necessary, close and delete the new channel. And I would do that by just using the same Boolean as we did before, if new chan do you close and deletes. That'll look very similar to this guy. But yeah, hopefully that is straightforward enough. If you have any questions, please contact one of us. Please DM me or email us or come to office hours. We'll be happy to go over it. But thank you very much. Good luck.